Okay, so I'm going to demonstrate how I would tackle refactoring this tic tac toe. Most of you, or all of you, should have taken your own crack at it, and I wanted to show you sort of how far you could take it. And as is often the case, I don't actually expect you to go this far. It would be kind of amazing if you did, but I just want to show you what is actually possible and what the result is when you do it. So I have copied in, I'm starting from scratch. I have this starter code as you had it. And the first thing I'm going to do, and we can see I've run it, and it works. Okay, so we're in our best place. We have working code. I'm going to delete that comment, so when I scroll to the top, I'm actually at the top. And most of the top of this is fine. The first thing that I see is this chunk of code, draw the board, and whenever there's a chunk of code with a comment telling you what the chunk of code does, that just says like a cry for help that it should be a function where the function name will tell us what it does. And you can almost even just take the take the comment and turn it into the name of a function. So I have to lowercase, I can literally do it here. I probably wouldn't normally call the function draw the board. I might say draw board or something, but that's actually fine. And then another trick is I just created the function name, like this line, it's the start of the function, and then I put the closing brace at the bottom, and now I'll use format document to get everything sorted. And this, I think, so now I have to check, are there any variables in here? And since this was already at the top level, kind of by definition, all the variables it refers to have to already be sort of global variables at the top level. So they're all just these constants, the left position, the cell size, and there's stuff I could do to tighten this up, and I may come back to that later. Now, whenever I wrap code in a function, I have to also add a call to the function at the right place. And I could put it right here, and this is what a lot of you have done, and it's kind of reasonable. But if you did that on your PR, I probably commented something to the effect of it's better to have all of the definitions first and then the code that does stuff. So I would actually go down to the bottom. And you can argue a little bit about whether this thing where we're calling register on click is something that does something or a definition, because it's got this giant function definition in it. But it doesn't really matter which order we do these things. So I'm just going to move that to the bottom. And then I'm going to generally put new functions in this space ahead of the register on click. So then this will be the beginning of, like here will be the beginning of the code that does stuff, not just defines things. So all these variables are defining variables. And then now we're defining some functions that use those variables. And I will check to make sure. And I did break it. Draw the board. Like I said, I probably wouldn't normally call it that. So if you do call the function, the name has to match. Oops, can someone win here? There we go. Okay, so that still works. Now I'm going to do the thing that we did in class today, check if there's a winner already. So I'm going to do it the same way I did, a little bit faster since we've already been over this. So paste the code in. This time it happens to be indented already, but I'm going to say, and I'm going to call it find winner, because what it's really going to do is return the winner. Put the closing brace after the chunk of code I just pasted in. I can delete that comment since the function name sort of serves the same purpose. Formatting document does nothing. And now, as before, I have to look at all the variables we reference. So I is obviously local, lines is global, R was from the surrounding environment of this code originally, so I need to make it a local variable here. And C, likewise, once I've declared them, I don't need to redeclare them. All these M0s, M1s, M2 are local. And then winner, we're assigning to it. If we made a local variable like this would just do nothing. It would make a local variable and assign it a value and then do nothing with it. The point is we want to return this value, as we discussed in the class and in the slides, and then in the chance that we get all the way through the loop without finding a winner, we want to return null. Someone asked today what null is. Maybe I've never explained that. It is just sort of an empty value for arrays and objects. It's very similar to undefined, not quite the same. It's probably not the greatest thing in the world that JavaScript has both, but I happen to use null here, so we're going to go ahead and do that. Then, as before, replace the initialization of null with a call to find winner. And now if we check, it's kind of hard. Oh, and then the other place, we have this same chunk of code. Do the same thing. And then the last thing, well, let's just leave it at that. Check, make sure everything still works. Good. Last thing, I happen to know that R and C aren't otherwise used. All the other uses of them were in the code we extracted, and so now we can define them once and for all in this function as essentially translating the x and y, or the y and the x, into the row and column on the board. Okay, so that's, and I just compile that, or run that, it still works. All right, the next thing, and I've mentioned this to some of you in PR comments or just in person, like this is a big chunk of code. Everything basically in this, between these braces, you like fold it up and see. All right, all of that code that just disappeared is a big chunk of code. It's not duplicated anywhere, but it's also has this pattern. There's a comment saying what it does, and so I'm going to extract it. I'll just leave a little marker here so I remember where I took it from. And I'm going to come back up to where I'm putting all my definitions, and I'm going to paste it, and then I'm going to write the function definition, and we'll call this draw winning line. Initially, we'll write this function with, as always, with no arguments, put the closing brace after the chunk of code, format document, and we can delete that comment. Okay, this time we have a lot of functions, or sorry, a lot of variables that are declared in the code here, and then one that we use immediately. So we're not assigning a value to winner, we're just referring to it. And so that basically says by logic, like we can't make that a local variable because we don't know what its value should be. So the way functions get values that they are not responsible for is as arguments. So that just sort of by logic, winner has to come in as an argument. And if someone passes us an appropriate winner, then we can use it here and here and here. And then everything else, I believe, is defined in this function, and then we call draw line. And so now we just need to go to the place where we want to call this function. So I'll copy this, just this name, so I don't have the problem I had before of calling the wrong function. And where I put my little marker, I'm going to call draw winning line. And of course, lo and behold, we have winner here. Now, I've mentioned to several of you, it doesn't matter that these names match. Like they don't have to match. I could, and actually in this editor, I could rename this symbol to W, and it would change to W everywhere, and this would work just as well. It doesn't matter what the local variable, the argument name is, but I'm going to put it back to winner. But because we cut and paste the code from somewhere where it was called winner, the easiest thing to do is just call the argument winner, and then the code all just works, I believe. So try it again. Okay, so we've extracted a third function. And also note, I'm moving all of these functions to the top level, meaning they're at the leftmost column. They're not indented inside the way they would be if they were nested with inside this onClick function. And so now we can see this onClick, register onClick, the function we're passing into it, like now it fits in the screen and we can see what's going on. The next thing I would do, the next thing I would do is this chunk of code, another chunk of code that has a comment on top of it. So I will cut that, leave my marker, come over here where new functions live, and what was that thing doing? I think it was, all right, let me just paste it. Draw the mark, I'll just call that make move. Like that's what we do when we make the move. We draw the mark and we record it. Again, no arguments to start with. Delete that comment. format to get everything indented right. And again, look at all the variables. So all these that are declared here, we don't have to worry about. Move is a global variable. It's defined up almost one of the first things in the file. So we don't have to do anything about that. These are all board left, board top, cell size. Those are all top level things. Marker we just defined. Board is another global. So this function was very easy. Oh, except I skipped over. So when we can translate or get these X and Y, we get it from C and R, which were the column and the row that we figured out back here in register on click. So those are, again, values that we're using. We're not assigning them because we don't know. That's the whole point. We're being asked to make a move. We need to be told which move are we making, and it's at a particular row and column. So now I believe all the variables that are referred to in this function are either local, global, or in this case, arguments. So now I go back to my marker and I call make move and I just pass in row and column. Again, the names don't have to match, but because we pasted in a bunch of code where the names were R and C, we might as well name the arguments R and C so everything just matches up. And so now, if this works, still does, we've extracted another function. So you see this is a pretty mechanical process. Obviously, I'm benefiting here from the fact that I have done this a few times in recent days. I wrote the code originally, and so I have some idea of what things should be structured. Right? I think I've explained to some of you that I made this assignment by taking an actual piece of code I wrote and basically defactoring it by taking all of the functions and moving them, like making them not into functions and just putting them in line. So there was clearly duplication. There were clearly functions that were sort of designed to be, or crying out to be factored out. Okay, so now it's looking like this is looking pretty all right. I might even switch some things around just on terms of order. So the first thing we do is we figure out the row and the column. Then we check if there's a winner, which is basically part of, it's a legal move. It's not a, like basically if there's already a winner, that means the game is over and we don't want to make a move. But that might not be totally apparent, like why this is, like why are we trying to find the winner right when they click? And it's because of the thing I just said, but we could make that more clear by refactoring. Also, this comment is like explaining what we're doing, but maybe we can just make that clear in the code. So I think there's a couple things to do. One is, like, so I'll take this comment. I'm just going to copy it up here. Just the comment. All right, and only do anything if it's a legal move and the game isn't over. So maybe even let's just split that. Like, there's a legal move and the game isn't over. Those are two things that we're going to want to be able to check. And so let's do the game over first, just because I want to. Okay, so the way we figure out whether the game is over is going to be with the function. Is game over, let's see. We'll just call it game over. And we want to return true or false. We're going to return true if the game is over. So the game is over if find winner is not equal to null. Oops. All right, so we look for a winner. There is none. And the move, remember we have this variable move that we increment every time we make a move. If the move is less than 9, right? So if there's no winner and we haven't made 9 moves, that means there's at least one empty square on the board and someone could go. Now it might be dumb in the sense that there's no chance of winning, but there is a square to be played in. So we'll say that. And if we wanted to change the logic of this, then this would be the function we would change. So the game is over if, oh actually wait, am I doing this backwards? If we find a winner Right. If we find a non-null winner, sorry, let's do it this way. Or, yeah, I was mixing things up. Or the move is equal to 9. So after the 9th move, we'll increment move one last time. Move will be 9, and the game is over. So if we find a non-null winner, or the move is 9, and you'll notice, like, we're not even using the value of winner except to check that it's not null. And we can delete this comment because it's clear what this function does. And so now, with that function in hand, we can come over here and slightly restructure things and say, okay, if not game over, and we don't need to get the winner anymore. Now we'll deal with the fact that since we just deleted the place where we declare the variable, I'll move the let down here. And then we don't need to check this anymore because we're going to actually nest this. So now let me fix the indentation. Since I just added this if up here, that means there's got to be a brace somewhere down here. I'll let the formatter figure out how they all line up. Okay, so if the game isn't over, not game over, which is how you should read that, not game over, then if this whole thing, we'll get to that in a second, then we want to make a move. After we've made the move, we check if there's now a winner, and if there is, then we draw the winning line, and the next time we check, the game will be over. Okay, so this expression that's left is this other part of that comment. Is it a legal move? So move and this. So I just pasted in that expression, and we do the usual thing, and I'll write it in this form. Do the usual thing, which is look at all the variables and see where did they come from. Okay, so R and C aren't defined in this function, and they're not global, so they need to come in as arguments. Which makes sense because the thing you're asking about is a legal move is very much like when we make a move. The question only makes sense if you provide some information of what you're asking about. You're asking about a particular row and a particular column. So this function will tell us if R and C are a legal move, and this is obviously assuming that the game isn't over, though if the game is over because the board is full, it will consider all moves to be illegal, which is good because you won't find a winner if the game is a draw, which is usually the case in tic-tac-toe. So that means we can replace this expression that we just turned into that function. If is legal move, RC, and so if the game isn't over and it's a legal move, make it. And let's see if I've got that all right. Good. Okay, and again, I can delete this comment because the code now basically says the same thing. Not game over, legal move, make move. Let's see, what else can I do here? So check if there's a winner now. This one's a little different. Like, this is fine. Another thing we could do just to show is we could make this const now because winner's only defined once in this function. Obviously, we called find winner up here, but we didn't assign it to a variable. So this is the only place we use find winner. I would even, like, this might seem a little silly to you, but let's see how it looks. So I'm going to take this chunk of code, which is basically getting the winner and checking and drawing the line, and even break that out into a function, maybe draw winning line. Get the formatting going, and I think that's good as is. Oh, wait, hang on, no. The idea that I wanted to do here. So I'm going to, like, we could leave it like this and just have it be a function, maybe draw winning line, and that actually should work. but I'm going to actually do it a little bit differently. And I'm going to instead make winner an argument. And so now this function is very simple. You give it a winner, and if it is a real winner, not null, it draws the winning line. And then all I got to do is call this function to get the value that we then pass as the argument. So this is maybe obvious, maybe not. Like we could have done this as with the line that I just cut, like make a variable, get the value, stick it in the variable, and then pass the variable in as the argument. But that's just like 2 steps going around your elbow to get to your thumb, as they used to say. And since we don't need the variable afterwards, we might as well just pass it in. And so this little chunk of code is very pithy. If game isn't over, and if we're trying to make a legal move, make it and maybe draw a winning line based on this. And since you kind of know, I mean, from the name tells you what it does, and obviously the maybe is like, maybe it's going to do it, maybe it's not. Well, obviously, whether it does it or not is going to depend on this argument that we pass it. So it's kind of clear, I think, clear to me. I guess I wrote it, so of course it is, but I think this would be clear to me what's going on here. And now you can really look at this and say, is this like the logic of tic-tac-toe? And say, yeah, I think it is. All right, so let's see if that worked. All right, so I've factored that out. So this is getting pretty darn small. There's a little bit of, yeah, I mean, now, okay, let's see, there's, okay, so what else do we have going on? We have, this is not terrible. It's kind of, I mean, it's 8 lines long. I think I said in the slides, like, rule of thumb, 5. That's pretty tight. Depends whether you count like the braces and stuff. But there might be some way. This is also kind of duplicative. Like we're getting an x1, like we're getting 2 x's, we're getting 2 y's. All right, to draw the lines, like the 2 vertical lines and 2 horizontal lines. Actually, let me do that. So again, I'm pushing this as far as we can. I'm not sure I would, in the real world, would bother. I might, but anyway, let's just show you how it can go. So let's say, so we're doing like these 2 calls to draw a line are drawing vertical lines from the board top to the board top plus the size. So let's make a function called draw a vertical line. And again, we'll just leave an empty argument list and see what we need. And we'll take one of these as an example. And format. And now we, again, look at the variables. Board top, board size. Those are all global. But x1, okay, so that's clearly the argument. So one nice thing is we only need to pass it in once to this function. And we can, this is a trick. So we copied this line in that used x1. There's another one that uses x2. We only had x1 and x2 because we had 2 instances of it. So let's rename that symbol to x. So now this function is just written, draw a vertical line at some x value, some coordinate on the horizontal axis. Okay, and so now we can at least use that function to draw a vertical line at x1. What's going on? And the same thing, vertical line at x2. Get rid of that one. And you can probably guess what I'm going to do next. I'm going to draw horizontal line that I can, I'll say y1 because this is going to be the same thing. I'm going to copy this in, fix the formatting, and then I'm going to rename y1 to just y. Horizontal line at y1 and y2. So, if all goes well. Oh, I guess we knew it went well as soon as the board was drawn. I didn't actually need to play it out. Okay, so again, like this is maybe silly, but it does have the advantage that like if I decided I wanted to change something about like, I don't know, the colors of the vertical lines to be blue, just change it in one place and boom, they're blue. Obviously not a huge savings since I only would have had to change it 2 places, but as a matter of principle, it's good. Now the next thing we can do is look at, okay, now that we've done that, x1 only occurs in one place. So we don't even need a variable. This is kind of like the thing before. We didn't need winner. We could just call the function that returned the value. And so just to prove that that works, there's the board. And by the same token, and the reason that we had to have variables before, or the reason we didn't have to, but the reason we did, was because in these calls to draw a line, we have to pass, like for vertical line, you got to pass the x coordinate, the same one twice. And I didn't want to write this whole expression twice, so I made a variable. But now that I've moved that into a function, that serves the purpose of making the variable, and now I don't need it anymore. So if now I've basically cut the lines of code in this function in half, albeit at the cost of making these 2 functions. But I would say that's, I don't know, just like super clear. Like you don't have to parse these to realize, oh, this is drawing a vertical line and this is drawing a horizontal line. You can just read it right off. Draw a vertical line. Draw 2 of them. Draw 2 horizontal lines. And then again in the, you could say, well, there's duplication here because we're calling these functions twice. And the only difference is like how much we move it over. Both these verticals start at the left and go over a bit, and both of the horizontals start at the top and go down a bit. So what if we did a loop? I'm going to do it this way. So this is not some syntax. All right, fine. I'll write it the way you know. We're going to learn it in a week or 2. So let I equal 1, I less than or equal to 2. So this is a loop that's going to run twice. And the reason I'm doing it that way is because now I can draw a vertical line with when I is 1, it's the same as that. And when I is 2, it's the same as this next line. So I can now get rid of that. So now I'm clearly going to draw 2 vertical lines. And similarly, for the horizontal lines, when it's 1, it'll be that. And when it's 2, it'll be this one. So I can delete that. And reformat. And so this is now the same number of lines, but arguably even less code. Like you have to understand this loop. Okay, there's a loop that runs twice, and then these 2 things happen, each twice. And there it is. Okay, so like I said, we're pushing this as far as we can. Find winner also has, wow, a lot of like these 3 chunks are all the same. There's a couple ways to do this. Maybe I'll just do this in steps. So let's make an array of marks. And we'll make it like this. And so now instead of these separate variables, I'm going to say marks 0 equals that. Actually, let me do it this way. I'm going to make an empty array of marks. And then for each of these, I'm going to push the mark at that particular row and column onto my array of marks. So rather than 3 variables, each with 1 value, I'm making 1 variable with an array that will end up with 3 values in it. And then I got to change these to marks 0, marks 0, marks 1, marks, shoot, what was that? Marks 0, marks 0, marks 2. Okay, so again, bet that still works. Oops, gotta make a winner. Oh no, it didn't work. What happened? Amazing. What did I do wrong here? Find winner. I can pop open the debugger and see no recent errors. All right. Well, that's fascinating. Marks push, marks push, marks push, mark 0. Oh, no, that should work. All right, so now you get to see me do. Now I could just like I'm going to give this a quick look. Let's see, is this going to print right? Oh, wait, what? Oh, yeah, it printed a bunch of stuff. Okay, so it was printing me the marks. What? Okay, this is generally a mystery. All right, so I'm actually going to demonstrate a different thing, which is sometimes when you're just trying to refactor and things don't work and you're surprised, like I made a change that I thought was uncontroversial. Okay, I just rolled back to a previous version before I made the change, and now I can try it again. What is going on? All right. Oh, duh. Okay, sorry. Yes, all right, I did it in the wrong place. Right, I don't want to make a marks outside of the loop. That was a rookie mistake. Okay, same thing, except make a new empty array for each line, because we only want to get 3. I should have even noticed that in my output. There was actually, it was printing a lot more than 3 things. I should have noticed that. Okay, so now we're going to do the same thing. Marks push. Marks push. Marks push. Marks 0. Marks 0. Marks 1. Marks 0. Marks 2. This time for sure. Okay, good. All right, so sometimes you're confused and you got to figure things out. Okay, it's not, I mean, that's actually not any better. In some ways worse. I had to add a whole line. But I think my idea was, so one idea was, okay, well, let's take this. And what if we had a way to get mark? And again, we don't know exactly what arguments we need. Format this. We're not going to push it. We're going to, so this is sort of similar. Instead of, we just want to get the thing. So we're just going to return the value that is otherwise going to be pushed. And the idea is that we're going to use this function to get the value that we're going to do here. So I'll even go ahead and say that. Get mark. And now he's got to figure out what arguments this thing needs. And so lines I, well, it's going to be a particular one of these. And rather than passing in I, why don't we'll go ahead and get the line. And so we can change all the lines to line. And so we can even go over here. Now say, okay, so we're clearly going to pass lines I, which will then become the valued line. And then this is getting the 0th element of the line and the 0th element of that. And then the 0th and 1. And then if we look at these other chunks, or these are zeros, these are ones, these are twos. So if we want to use this function in all three of these places, then clearly there's some different index. Let's just call it J. I'm going to call it P for the position in the line. So from the line, we're going to get a particular position, 0, 1, or 2. And then the R is the 0th element, and the C is the first element. And then we're going to use board, which is a global variable, to get the mark out of it. And so that means, so lines I and 0. This one, let's copy this. Actually, we'll just copy this. 1, 2, 3. We're going to be 3 of these. 1 for 0, 1 for 1, 1 for 2, and that replaces all of that. I believe. Indeed it does. And now, since it's all in a row, we could actually just get rid of, we don't need to even push, we can just build up an array out of these values. So this is a little afield from the sort of simply extracting functions, but it is showing some other ways to remove duplications. In this case, it was just some, I guess I extracted this function. So actually, I take that back. Absolutely showing how we can use even a really simple function like this to get rid of some duplication. And so now this is a little more obvious, and I could even go so far as to say, let's copy this and make a plural, get marks, that again, instead of assigning, is going to return. And again, instead of, we don't have access to I, so instead of lines I, we'll just say line in here and leave it to the caller, which is going to be right here, get marks for lines I. And that also has a nice, we only have to index into the lines once. We get it, that gives us our marks, and now we use the marks to check if this line is a winner. But wait, there's more. This expression is complicated enough to me that you have to parse it to understand what it does. Like, why is it checking whether this is empty, and then these are the same, and these are the same? And you can figure it out. Like, it's not rocket science, but what if we made a function all the same that took a set of marks and even if it just return that thing, which I think I just copied. And in the interest of names being meaningful, I'm not including the it's not empty part. I'm just checking, given a set of marks, are they all the same, which we achieve by checking is the 0th and the first the same, and the 0th and the second. And this obviously assumes that this array is only 3 items long. Wouldn't work for arbitrary arrays. And now we call that function instead of that expression. So again, and this is not like, all I did was wrap this thing up in a name, but the name is a little bit more meaningful. And now find winner, which was originally like 12 lines long, is pretty short. And I guess just, well, why not? No, actually, I think that's maybe enough. I was gonna break the body of this out into its own function that, but then we'd have to check whether it's null. So I think that's probably good. I mean, I guess, actually, we'll do this. Again, I am pushing this as far as we possibly can go, in some sense. So is winner is really the question we're asking. And that is this expression. And so that's just combining. And I could have made this like the original thing with ANDed these all together, but I think this is still more clear. Like we're checking, it's not empty, and they're all the same. And this is so short that we can write this function in shorthand form. This one too, probably. All right, which is nice to show that all they're doing is computing some value. And so now, you might think, well, that was silly to make a whole function that for something that fit on one line. But now we don't even need marks except to pass is winner. And so we can get rid of this variable, which I think is good because whenever you have a variable, you have to think where is it used. And if it's only used in one place, it's better to just pass the value, like call the function or do whatever it is that gives you the value for the variable and just use it where you need to use it. So now find winner is quite short. For each of these lines, if it is a winner, and actually maybe this is maybe this is all right. Now I'm getting really into the nuance of stylish code. I'm going to take back a little bit of what I just said. I'm going to have is winner be a function of the line and get the marks from the line and then return based on those marks, is this line a winner? Because then that lets us write this as for the line. If the line is a winner, return it. Otherwise, return null. Assuming I haven't messed anything up, that all still works. Okay, so not sure exactly how long I've been going here. Probably too long once again. But that gives you a pretty strong flavor of what we can do. All right, I will do one last one, and then I will leave one thing undone. So make move. Another test of whether a function is good, beyond like is there duplicated code or are there big chunks of code, is kind of, well, I guess this is the big chunks of code, but it's kind of like, does it do one thing? And if it does two things, maybe split them into two functions just so you can see what those things are. So make move, actually, if we remember, originally the comment about this said like draw and record the move. So this make move is really doing two things. And so if we look, these three lines are about drawing. And so let's draw mark. Format the document. And you can kind of tell that these are about drawing because this is the lines that deals with X and Y, which is like X and Y in the graphical coordinate space. And like many of these functions that get an X and Y, they start from a row and a column. So those need to be the arguments. Those are the variables that were, right, they were the arguments up here, and now they're the arguments here, but everything else is global. And so, and let's see, and then marker was defined in the function that we're coming from, and so we're going to have to pass that in. Because that is a variable that we use the value of. We don't assign a value to it. Therefore, someone else has to tell us what the value is. So draw marker at row and column, and now this function is also shorter by several lines. So. And it's just clear. We get the mark, this little bit of logic of like rotating between X and O. We draw it, and then we record it on the board, and we update what move we're on. So that is also, and this takes some getting used to, and I know that like in some ways a file of code like this with all of these little functions might be daunting in a different way than a file with just like one giant function that does everything. Is at least kind of like with the recipes, if you're just trying to follow the recipe. In some ways, it's easier to read all the steps in one line. But the advantage here is, A, you don't have to follow these instructions. You just have to see that they do, in fact, fit together. And the names give you a lot of useful information about what each bit of code is doing. So we draw a board. How do we draw a board? Well, we draw some vertical lines and horizontal lines. How do we do that? If you care, like, you could just stop there and be like, well, I assume they draw vertical and horizontal lines. But if you really want to know, you can look. And in this editor, you can even like hide these things. So you're not bothered by them all the time. You know, getting the mark, get marks, all the same. There's some, you know, you can decide whether you want to put like the higher level function first and the lower ones below it, or vice versa. And now that is about everything. I have chopped this down to a lot of little functions, but the basic, like the actual program that does stuff, is now fits in, I don't know, 13 lines or something. So that is pretty good. And the one big chunk of gnarly code is this thing. And the problem with this is actually not so much that it's ill-factored, is that I wasn't fully on my game when I wrote it. It can be written much more simply, but it's not exactly a refactoring. It's just to like realizing some facts about math. And I don't want to explain all of those right now. If you've been watching for plenty long enough, I'm happy to talk about this with anyone who wants to, but I'm going to leave that there for now. So hopefully this was useful. Hopefully you've really tried to do this yourself and therefore were better able to understand what I was doing. I know it went fast. Obviously it's a video, so you can slow it down or pause, go back, whenever you want. And of course I'm happy to talk about anything that I discussed here. So if you watched all the way, thank you for watching. As always, I hope you got something good out of it. See you next time.